Well, thanks everyone for having me. Good to be back in Edinburgh. So I'm Nash, as we've said a couple of times now. And I'm going to be talking about modern C++ testing with Catch2. Some of you may be wondering what Catch1 was. But actually, show of hands, how many people have actually used Catch already? So a handful. How many people have never heard of it at all? So quite a few. Excellent. Well, I've done a few talks on Catch before. This is sort of a completely revamped, updated one. Talk about Catch2 as well. But there is a bit of a summary of the old stuff in here as well. So hopefully we've got something for everyone. As I alluded to earlier, I also work at JetBrains. I'm developer advocate for the C++ and Swift tools. So that includes CLion, also ActCode and ReSharper C++. Yes, we do free licenses for open source developers. There's a number of other opportunities for free licenses as well. In fact, for user groups, we do a scheme where you can raffle away free licenses every month, so maybe we should talk about that.
Okay, cool, yeah.
Cool. But I'm not really going to be talking about JetBrains stuff tonight, although CLion will come up in one of the demos as well. But feel free to talk to me about it afterwards, of course. And actually, I just wanted to explain a little bit about this slide. Some of you may be wondering what this is. I know I was when I first saw it. I was just searching around for Creative Commons licensed images that had the word catch in somewhere, and I stumbled across this. And on the Flickr page for it, the photographer had a bit of a story behind it. And he said it reminded him of these superheroes that can catch speeding bullets. That's where the catch part comes into it. And you can sort of see that, streaming of this bullet-like object being caught. But it's actually a handrail. Just a metal handrail, taken with a really narrow depth of field, so you can see that blur coming straight in. I just thought that was fascinating, so I decided to use that as my title slide. This talk is also brought to you with the help of, well, not that, wrong button, sorry. Classic programmer paintings. If you haven't seen this is a great site. It's a Tumblr. And each post is a classic oil painting, and then a caption that's something to do with software development, programming, agile practices, whatever. Some of them are really amusing. They make a great source of backdrops for slides as well, so I've used them liberally throughout this talk, just in case you're wondering where they came from. By the way, links to all of these things, including that slide, title slide photo, and this, and all the other references and things. Right at the end, there'll be a link to a page on my website that has all of the references there, so just wait till the end for those things. Also brought to you with the help of some tweets that I thought were appropriate, that I've thrown in. Words of wisdom, I think. But let's get stuck in to the material. And I actually want to start just by talking about testing in general, just to get us warmed up to the subject. And this fundamental question, there's a classic programmer painting, by the way. The fundamental question, why do so many people not write tests at all, first of all? I'm sure that's nobody here, or maybe it is, and that's fine too, you've come to the right place. But we can probably expand that to the whole room with the second part. Why do we not write enough tests? When was the last time you finished a project and you said, yeah, I wrote just enough tests for that? I don't think I've ever said that. We can always write more tests, but what is it that stops us from doing it? Why do we not write enough tests, or any tests sometimes? And I put some candidate answers up here. You can probably relate to these. I'm sure you can think of more responses as well, but I think these sort of really get to the heart of what it is for most people. Starting with, just that it seems like extra work. And one of the most endearing properties of programmers is that we're lazy. We don't want to do extra work. So, if we're asked to do something extra, then why would we want to do that? And so closely related to that, this idea that, well, I've already checked it manually somehow. I know that it works. Why do I need to do that extra work to check it again? It's all extra stuff, and I've done my job. I want to move on to the next thing now. That's what we're thinking. The last one we don't hear quite so often anymore. It still comes up from time to time. We have another team, test team, that does that. In fact, this is sort of coming back a bit. Some of the bigger technology companies like Google and Facebook, they have this role, developer in test. You both heard of it. So developers whose sole purpose is to write testing software and frameworks and actually help with the actual testing itself. So to some extent this is coming back in, but over the last sort of decade and a half or so, this sort of developer testing culture has really sort of gone mainstream. So we do hear less of that, but I think the other points really still stand. But I want to drill into this bit in the middle again, this idea that we've checked it manually. What does that really mean? And if you're not writing tests at all, or think back to a time when you didn't write tests, how did you know that your code actually did what you intended it to do? It's not a trick question. Really, you probably just ran your application and visually inspected the output, or if it's a UI, you poked around to the point where it's going to do what you intended to do, see if it does it, and you get a feel for whether that was right or not. And, the interesting thing about that is that sort of testing can actually be fun. In fact, for many of us, this is why we got into programming in the first place. We solve some technical puzzle in order to achieve some result, and then we see that result. This is what we wrote the code for. It's doing it. We get that buzz, that dopamine hit that actually take us on to the next thing. That's the fun in programming. It's not work. So if that's what we mean by having already checked that it works, then that's why it's not extra work. But there's an important caveat to this, and that is manual testing can be fun, but only the first time you do it. So the problem is, you might verify that this thing does what you intended it to do now, but what about all the other things you broke along the way? You have to keep retesting, and again and again. So we don't do this very well. We don't go back and run all the same tests again and again, because it is tedious and repetitive, and this is where this idea of work comes in, and it is repetitive as well, and it's tedious. We just don't have the discipline or the time, let's be fair, to do that sort of manual testing again and again every time we make a change. But who's good at doing that sort of thing? Computers. That's what they're designed for. And that's when we're writing tests, that's what we're leaning on. We're telling the computer how to do these repetitive bits. So if we sort of give up after that initial manual testing, we're missing out on all of that. If we flip this around, there we go, and ask the opposite question. Why should we write tests? Well, that's why we're not writing tests, but why would we do it? What's the benefit we're getting from it? And it sort of breaks down into a couple of things. What we've been looking at so far is this idea of correctness, that it actually does what we intended it to do, or meets some requirement. And that's usually what we think of a test as actually doing, but there's a flip side to it, this idea of testing for regressions. And there's a subtlety here that's so simple you might miss it, and that is that tests play two roles and actually flip from one to the other. When you first write a test, you're testing for correctness. You're making sure that it meets some requirement or some expectation. Once it does that, once it's achieved that role, it flips to this concept of a regression test. It's now telling you if you've broken it. In TDD, we have this idea of being red when you're actually making the test pass in the first place. Once it passes, you're green. You don't want to go back to red again. So that's a really interesting way of splitting up this idea of tests. And talking of TDD, the idea is that we'll write the test before the code. Why would we do that? That's sort of the secondary question here. The first part is, well, I've said codify expected outcomes. And what I mean by that is, before we start writing code, you've got some idea of what you intend it to do. Usually, anyway. I mean, sometimes you are doing something more exploratory and you're actually discovering what it's doing. But most of the time, if you're writing code and not having an idea what it's meant to be doing, you're probably doing it wrong. Here's an interesting thing about human psychology, is that we have these different mental states that we go through. We don't have this consistent worldview all the time. And when you're in this design frame of mind, you're thinking about requirements, and you're thinking about design and design principles and all that sort of thing, well, it's actually quite easy at that point, when you have in mind what you expect it to do, to be able to write that down in code. Then you flip into this implementer's state of mind, where you're all about the code and the implementing and all the technical details. You can really get lost in that. You can forget about the actual requirement you were originally meant to be implementing. Get carried away, you can go on gold plating it, or maybe not quite doing the complete requirements, or doing something completely different. If you've actually written that down at the start in a way that the computer can be checking, then it's got your back. It's doing that checking for you. You can freely switch your mental state without having to worry about continually flipping backwards and forwards. It will save you a lot of mental effort. And then there's a whole load of reasons why we might write tests first. I just picked two highlights out here. The other one, it's a bit nebulous. You may have heard this expression before, that guides our design or exerts a design pressure on our code. What that means is that testing and TDD, they don't automatically make your code clean and imbue it with correct design principles. But what they'll do is they'll amplify when you've done it wrong, so that you immediately know. What happens is it becomes hard to test. If your code is hard to test, it's because you haven't actually put in those design principles that we were meant to put in. Things like isolation, cohesion, loose coupling. All these great design principles that we, after years of experience, we learn the importance of. They're still hard to actually put into our code. But again, we're lazy. So if the code becomes hard to test because we're not putting them in at the start when they're actually easier, we're more likely to do that extra little bit of work then to build those principles in, and then actually make the testing easier. So it's a win-win situation. But you do have to know what the principles are to start with. That's the caveat there. So there's another reason why we might want to write tests. This is the low-level reasons. But the big picture reason is that bugs in our code can actually cost, well, in many cases, real money. And I just wanted to dig into that a little bit, because we know this is the case, but very often it's difficult to actually pin that down. If you write a bug in your code, how much does that really cost? We don't always know that, but in some cases we do. That could be quite interesting, maybe even entertaining to dig into that a bit. So one of the earliest recorded bugs that cost money, real money, July 22nd, 1962. So it's 55 years ago, just a few weeks ago. The Mariner 1 rocket was destroyed on takeoff due to a code error. Now, admittedly, this wasn't the type of error that probably would have been caught by unit tests, because it wasn't an error in the source code, it was an error in the translating into punch cards. But nonetheless, it's just like a single figure, I think, went wrong, and as a result, they lost the whole rocket. At an estimated cost of $135 million in today's money. So think about that next time you make a one-character bug in your code. How much that can actually cost. But moving on a bit, sticking with rockets. But 1996, the Ariane 5 rocket, on its maiden launch, self-destructed, carrying a number of satellites because of an integer overflow. And the really ironic thing with this one is that code wasn't even meant to be part of that mission. It was just left over from code they'd reused from a previous flight. But it triggered the self-destruct mechanism. They lost a whole lot. Again, estimated cost of over $370 million. If you want to know more about this one, by the way, it's a favourite of Kevlin Henny's, if you've seen any of his talks. I've got a link to one of his talks at the end where he goes into this a bit more, including showing the actual source code that went wrong. So, yeah, you'd think we'd do a better job of this. I mean, it's not rocket science, is it? Come on. You know who this guy is? Tony Hoare, who self-confessed to what he calls his billion-dollar mistake. Some of you may have heard of this. So this was not a bug in source code so much as a feature that he introduced into programming languages, into, I think it was Algol originally. It's now been replicated in many programming languages. which is, of course, the null pointer or null reference. He said he put it in because it was easy. How often have we written something a certain way that we've regretted later because it was the easy thing to do? Well, he's responsible for what he claims to be at least $1 billion worth of mistakes. I think maybe that's even conservative. Now, again, you couldn't catch this with a unit test because it's a language feature, but we have to write a load of unit tests as a result of this. So I think it's still relevant. So we've got up to $1 billion, but it gets worse. So 2002, there was an NIST study, and I can't remember now what NIST stands for. I think it might be the Nash Institute for Science and Technology, something like that. But I think it's the UK government agency anyway. They did a study into software bugs and their cost. 2002. Here's some choice quotes from that report. Software bugs are costing the US economy, it's just the US economy, an estimated $59.5 billion each year. So really dwarfs even Tony Hall's contribution. But then improvements in testing could reduce this cost by about a third, or $22.5 billion. They're not quite sure why they came to this idea it's only a third. I would have thought you could probably get a bit more out of it than that, but even so, that's a lot of money on the table. The general consensus seems to be that the current state of the art with respect to testing is poor and can be sufficiently improved. Now, this was in 2002, just before sort of the big agile revolution took off and developer testing really sort of got into the mainstream. So you could make an argument that it has actually improved since then. Whether it's sufficiently improved is debatable, but it will be interesting to see a similar study conducted today. But even if testing itself has improved, or our usage of testing, I think the whole scope in the industry for software and the implication of bugs has also increased dramatically. So I think it's probably going to be a bit of a wash. So bugs cost real money. We don't always see that, and sometimes that can be long after you've left a project that this kicks in. So I think that's been a bit serious. So back to Twitter for some light relief. We do have to look a bit harder for the bugs sometimes. Back to our paintings. So in summary for this section, we do know that we need to write tests for various reasons, including money. But it just seems like too much work to write them. So a couple of things we need to realise. First of all, it's less work in the long run. It seems like work up front, but remember we said what you're doing is you're capturing that point at the start when it's actually fun to verify what you're working on actually does what it does. And you're letting the computer repeat that for you. That was work you should have done anyway. So you're saving time there, but you're also then saving the time that you spend going back later and fixing bugs. So on many levels, you're saving work in the long run. But then here's the bit where we finally get to link into catch and testing frameworks. Our testing environment should be, therefore, as easy to set up and use as possible. Because of this idea that we're afraid of extra work. Any extra obstacles we put in our way to stop us from testing are going to slow us down. So, the minimum possible friction. Now, the reason I set this up as being so important is because this was one of the main motivating reasons that I actually decided to write my own test framework about 7 years ago now. Because I was working on a new project and I was trialling all these C++ test frameworks, all the usual suspects, and was just really struck by just how much work it was to get them up and running and to use them. And I won't mention any by name like Google Test. Some of them have got better in the meantime, but still, I really wanted something where you just get it up and running instantly. So I think it's a good time for a quick demo. This won't be that new if you've already used Catch, but if you haven't, this will give you a good idea of what I mean by all of that stuff. So let's see if I can switch it over. Right. that look readable to everyone? Okay. So this is C-line, by the way. I'm going to create a new, fresh project. Never been compiled before. And give it an imaginative name. So, as any IDE will do, it generates some rubbish stub. We're not going to need that at all. Let's get rid of it. What we're going to do is just include catch, because catch is just a single header. Now, that doesn't compile, and this is how you do TDD. You start off with code that doesn't compile. That's the first failing test. And the reason it doesn't compile is because we don't have the header. Right? That's how fundamental TDD we're going. And C-line is telling us that straight away without even having to compile. So what we're going to need to do, of course, is get catch. Now, I used to actually do the downloading for the internet part as well, but with unreliable Wi-Fi networks, that was always a bit dodgy. So I've got one on my desktop here, so just a single file. And if I go to, I've got where I put it now. Yeah, for some reason in here, okay. So there's our project folder. Drop it in there. That's it. That will now compile, but it won't link. So there is one more step you need to do. Because although catch is a single header, you still need the separation between the parts that would normally be compiled into CPP files and the headers. Otherwise, compile times are just too long. But also, you need a place for it to generate main and things like that. So, oops, you just have to define catch config main. There's a variation on this, which I'll show you later, by the way. And that's it. That should now be a complete application. This is compiling the whole of catch, so just take a moment or two. There we are, we're done. If I run that, you can see it used to tell us there's no test run because we hadn't written any. It's fine. But if we go to the command line, what did we call it? If I run with --, you can see it's got full command line processor built in. It's telling us this is actually Catch2, the beta release. So there's quite a lot you can actually do there without writing any code at all. But let's write some code, see how it goes. So that it you can write code here, but just so that it compiles a bit more quickly, I'm going to create a new source file. Include catch again. Right. So we're going to create a new test case. So has anyone here not used any test frameworks ever? So everyone has used some sort of test framework. Apart from this one guy. All right. Most people have used some test framework.
Yeah, that's why.
Most other test frameworks you'll be familiar with. When you write a test case, you have to give it a name, and that name must be a legal, in this case C++ identifier, which means you've got to use all sorts of weird camel casing and other limitations on what you can do. Well, in Catch, first of all, we don't even need a test case name at all, but we will give it one. Let's call it Life the Universe and everything. So you can probably guess what sort of example I'm going to give. But it's a free-form string. We can use any spaces, any sort of punctuation in there. But we still write it like a function, so that's quite nice. So what we're going to do is require, so that's the name of the main assertion macro, that 6 times 9 is 54. Yes, it is. Let's see what that does. See, that compiles a bit more quickly now. Sorry. Completely ruined the joke. Should have written 42 the first time, yeah. Okay. actual evaluation is 54. And in fact, you can see that down here, giving us the breakdown of the expression, even though we haven't had to separate it up in the macro. Again, most test frameworks you'll have to write something like assert equals and then split it up. But we've written just a natural expression, and behind the scenes it's used expression templates to break that down for us. So that's quite nice. It also hasn't forced us to identify one side or the other as the expected and actual result, which I always get the wrong way around, which is really confusing. It just says, well, you know, that's how it evaluated. What you wrote, and then the evaluation. So that's quite nice. And it's given us the usual things, the test name, file and line number, usual suspects, and a summary at the end. So let's see what went wrong. I think my maths is fine. The trouble is I'm doing it in the wrong number base, of course. It should be base 13. So hopefully, there we go. Got a little snippet I prepared earlier for a base 13 converter. So let's use that. And that returns a string. It can't represent the digits. Let's try that. And that all passes. It's quite nice. So while we're here, let's go back. Run it the same way there. If I run with -s, again, will show us the breakdown, even though it passed. We can also do things like, so we can give it the whole name here and it will just run the test, but we don't want to type the whole name. We can use wildcards. And we've got this thing called tags. So a test name must be unique, because it must be uniquely identify the test case within the application, within the test application. Tags don't need to be unique, so we can group tests according to tags. Any test can have more than one tag, and tags can apply to more than one test. So if I just build that as well and run it, and I can now run that. Run it by test, by tag. And of course, you know, I can list all the available tags and so on. Okay, we'll come back to tags a little bit later, but that's the first demo to show you. Okay. So when I've done catch talks before, I've given a few demos to demonstrate more of the features, but because I want to summarise the older stuff, one of the important properties of catch was summarised in this slide, and this is this idea of sections, which at the time was pretty unique to catch. A few other frameworks have adopted it now. And what sections allow you to do, probably best described by comparing it to what other frameworks do. You've probably seen test fixtures, which would be a test class that you write methods on. Each method is a test. And then you can have setup and teardown methods, or constructor and destructor, that will run before and after each test case. It can be very useful for the common setup and teardown code. So you can do that in catch, but I almost never do, because sections allow you to do all of that and more. And all sections are just parts of the test case that will be sort of separated out and run in isolation. And when I say in isolation, I mean each leaf section will be executed on its own from the top of the test case. Just to put that a little bit more visually. First time this test case runs, it will run everything at the top and then go into the first section. But then when it comes out, it skips over any sections below it. So it just run that one section. It will then execute the whole test case again from the top, but it will skip over the first section that it's already seen. And now it will run the second section. But you can also nest sections. You can have a section within a section. That's why I talk about leaf sections. So we'll go into this second one as well, this third one, the nested one. And then it will skip over any more at the bottom. And then finally, the third time through, it will skip over all of that and execute that last one. So it's actually more complicated to explain than actually use in practice. What this means is that all your common setup and teardown code is just naturally on the stack as you would write normal C++ code. It's a much better fit for the language. And it means you can visually see everything in one place rather than having to hunt around different places for what's logically part of the same code. So once you get used to sections, it's just a much more natural way to componentize your test cases. And in fact, once you do get used to sections, there's an extra layer on top of that you can apply. Taken from the vocabulary of BDD, the given, when, then scenarios. So here, the scenario macro is really just an alias for test case. All of these macros just add a little string prefix. So that should be scenario colon, and then the name of the scenario. You can see I've given it lots of tags there as well. And then given, when, and then, they're just sections. Again, with the prefix. But look how this reads. Just sort of a natural language. So, at the top, given an empty vector, well, we give it an empty vector. Even verify that it's actually empty. When it is made larger, then we make it larger. Then the size and capacity go up. And we verify that the size and capacity go up, and so on. So we're writing in natural language what the requirements are, according to a structured framework, and then we actually write the code in line with that to do it. So it's really trivial to verify that you're meeting the requirements directly in the code. And then here's the interesting thing. If one of these fails, in the output, this is the test name. It's just a natural language scenario description that you could show somebody non-technical and they'll be able to follow it. Maybe not in this example because it's talking about implementation of a vector, but you get the idea. And I just find that this is just a really nice way to structure your tests so that you sort of think about what you're doing, how you're setting things up and getting there. And because of the ability to nest sections, you can have this common setup code and have multiple scenarios effectively within a single scenario. And each one will have its own scenario output. So,
are those just synonyms for section, essentially?
Sorry?
Are the given, when, then essentially just synonyms for section?
They are synonyms for section. The only difference is they have these string prefixes that will appear in the output. So you don't have to write given. Okay, so catch is not just for unit tests. That's why I put this one up. In fact, integration tests, we haven't really talked about them, but integration tests are another type of test that you write at the code level. So catch is good for that. But one useful aspect of catch is the tags. So if you tag your tests integration, you can run all your integration tests together. You can also hide tests with the dot tag. So if you say dot integration, then when you run all your tests, by default, it won't run the integration tests. So you can quickly run unit tests, and then when you want to run integration tests, you just say square brackets integration. So putting a unit test and integration test in the same executable can be a really nice thing to do. Okay, back to the paintings. Here's another classic oil painting. This is not from the classic programmer painting site, but it is a classic oil painting by Monet, of course, one of his more famous ones, the Japanese bridge. And this was painted over 100 years ago. It was 1885 or something like that. Whereas this photo of the same bridge was taken a couple of weeks ago with my family on the bridge. We were on our way back from holiday in Spain. We dropped in Giverny in France to Monet's house and gardens, where this all still is. So if you're ever that way, highly recommend going to visit. The reason I put this up, though, is just to demonstrate that forward movement through time, 100 years ago today. Because now we're going to talk about what's new in Catch. I know, it's a loose link. It's good if you just get my holiday pictures in there. So, what's new in Catch and Catch2? Because I promised Catch2. In fact, before we get to Catch2, there's actually quite a lot that's new in Catch Classic, as we're now calling it. Over the last year in particular, quite a lot's gone in. I haven't talked about these before. Mostly not blogged about it either, so this will be new to a lot of people. Just going to whiz through these. So, talked about tags. I reserved all tags that begin with a symbol for use by Catch itself, particularly like exclamation marks, dots I already talked about. And I've started implementing some of these now. So, exclamation mark should fail, and exclamation mark may fail. But we'll annotate a test such that if it does fail, you'll see the failure output, but it won't fail the whole test run. It's not often useful, but when it is, it can be really useful. And there's a few other tags as well like that. I'm not going to go into them in detail. I did do a blog post on this one. There is a reference at the end, so have a look at that. But my other favourite special tag is hash. And at the moment you have to run with the -hash command line option. And what they'll do is automatically add a tag to every test based on the file name. So it strips off the parent path, strips off the extension. So if you've got a test file, say mytests.cpp, then every test in that file will be tagged #mytests. So you can run all tests in that file really easily. Quite a nice feature. Matches. I've actually been in Catch for a while. They weren't documented, and I wasn't really pushing them because I wasn't that happy with implementation. It's a bit complex, a bit over-templatized, so they were sort of experimental. Sorry, I had a question.
Just on the previous hashtag.
Yeah.
Hashtag.
I hadn't thought of that one.
You say it strips off the path before.
Yeah.
So if you have two files with the same name,
They'll have the same tag.
have the same tag.
Yeah. That's been mentioned before. No one's ever reported a real problem with it. There's possible workarounds, but I'm inclined to think it's a non-issue. If it's important to you, just give them different names. So matches. I've rewritten the whole thing. It's much simpler now. Happy with it. It's fully documented. Now, if you don't know what matches are, they're just a way of writing custom composable assertion objects. For example, there's a set of string matches, such as starts with. So you can tell if a string starts with a substring, and you write it as require that, or check that your string starts with the substring. Because they're composable, you could say, I want to require that this string starts with this string and ends with this string, or contains this string. And you can actually put these together in quite complex ways. There's also some matches in there for vectors, so you can tell if a vector contains certain items. There'll be more going in, but because this is now user extendable and fully documented and quite simple, you can just write your own matches to do pretty much anything you want, and you get the benefit of the composability automatically. That's quite nice. Reporters. Catch has a modular reporting system. When I ran that demo earlier, the output was being shown by the console reporter, which is the default you get when you don't specify anything else. But right from the start, there's been an XML reporter and a JUnit XML supporter, which are both useful for continuous integration, for example. Slightly more recently, I added a TeamCity reporter, and I did this before I joined JetBrains, I should say. So if you're using TeamCity, that'll output in native TeamCity format, which is quite useful. But now been a few others added, like the TAP protocol, Test Anything protocol reporter. There's a compact reporter that's like the console reporter, but just outputs everything on one line, or each test on one line. And a few others as well. Reporters are also user extendable. You can write your own. But closely related to that are listeners. They use the same interface, but they're just for a different purpose. So rather than reporting the output, therefore listening to events within the code. For example, if you want to do something at the beginning of every test case, you can do that. So you've got all of those same hooks, event hooks. Running individual sections. So I showed earlier how you can run an individual test case or a group of test cases. Now you can do that with sections. The caveat is that if you have nested sections, you have to specify each one from the root to the leaf. Which can get a bit tedious if you're doing it by hand, but this is great for tool integration. So C-Line and ReSharp and C++ have Catch integration.
Maybe you mentioned it before. Can you run everything except some tags? So
Yes,
then
you can.
or let's say you give it an exclusion
Yeah.
list of tags.
Yeah, so I think it's the prefix to the tilde character,
Okay.
and that's an exclusion.
Okay. Cool.
You can actually, there's a fairly simple language for composing
Okay.
tags and things with exclusions and so on. That's all documented. You can definitely do that. But yeah, in terms of running sections, within C-line, for example, you can put the caret in a section and say to run just this section, and it'll just run down to there. So that's quite nice. And then performance, I put last. And this is both runtime and compile time performance. Runtime performance was a non-goal originally for Catch. But over the years, a lot of people have said that that is important to them. They're using it with large volumes of tests and data and so on. So that's been something I've been looking at quite a lot. Still quite a lot of low-hanging fruit. So that's an ongoing effort. Compile time performance, I'd always felt was quite important. That's why I have this separation with the main file where you have to do the catch config main. So that most things get compiled into there. But it seems like there's still some left on the table, so that's also being further optimised. And that's again ongoing. So that's Catch 1. What is this Catch 2 I've been talking about? So it's obviously the new major version of Catch, but why is it a major version? So the main thing is that Catch Classic, up until today, will continue to be, only relies on C++03, or at a push even C++98. But Catch 2 now requires C++11. In fact, I said maybe even C++14. I'm still leaving that open. I don't want to exclude too many people, but we're keeping Catch Classic around as well. Maybe worth moving on. The only reason I'm not saying C++14 right now is that most of the only usages I can think of it will be just internal to the code base and fairly minor cosmetic things. Which would be nice, but maybe not enough to rule out whole classes of people. But I'm interested in people's opinions on that. Do let me know. But what does this mean for users? So the first thing to drop out of this, because we can now rely on variadic macros, is that we can solve the problem of commas in assertion macros. The old problem of commas in macros being interpreted as macro arguments, even if they were meant for a template or something. Now we just reassemble the variadic macros before we pass back to the real code, and that all works quite nicely. Technically, I could have done it before because we did actually do some stuff with variadic macros conditionally, but it just meant we had loads and loads of code duplication anyway. So now it's been much simpler. Small thing, but it's quite nice. More performance. As I said, that's an ongoing effort. There are some certain things that have dropped out of being able to move to C++11 there as well. In fact, I've rewritten the whole expression template layer now with some slightly more modern code. So it's a lot simpler. Now, the last two ones are interesting. New Clara. Now, Clara was the command line parser. So Catch itself has no external dependencies. But early on, I think around Catch 1 timeframe, I spun out the command line parser into its own library called Clara for command line argument rearranger or something. I can't remember the acronym. And then I wrote it in such a way you can embed it back into Catch or any other application. But of course, that was also limited to C++03. And I had a couple of design decisions that I, let's say, have revisited since. So I took the opportunity to completely rewrite Clara as well. It's got a slightly different interface. I think it's much cleaner. It's also C++11. And that's now being used back in Catch. But the reason I called this out as a big new feature is because the new Clara is actually composable. And by that I mean the parser for each option on the command line is a complete parser. And you just assemble composite parsers out of that. And what that means is, where Catch defines its own composite parser for its command line parsing, you can grab hold of that, you can add your own bits to it and pass back your version, and now Catch will actually parse all of your command line options as well. So you can easily extend the command line options. which is really useful if you want to parameterize your tests based on input from the command line, which is an often requested feature. And in fact, I'll give a little quick demo in a moment because that will demonstrate a couple of things at once. And then, final big new thing, still experimental, it's not finished, micro benchmarks. It's been something I've been toying with the idea of putting in for a long time. And part of me has been pushing back on it because it's not really part of a test framework, or a unit test framework at least. But this also feels right to offer this at the same time, largely because it uses most of the same sort of infrastructure, just a little bit extra. So I finally put it in. It's actually working quite nicely, and I will very briefly show you that as well, and exactly what I mean by that. In fact, let's do that now. I'll come back here. Are we okay for time, by the way? I don't know what time we need to finish. Okay. Right. So this is where we were earlier. Go back to main. So we just have two lines in there at the moment. The include for catch and this hash define catch config main that generates the whole of main for us. But if we want to write our own main, we can do that as well by saying catch config runner. And now we have to define main. And there we go. We've got that. It's meant to save you typing. So here's one I prepared earlier. So this is so far still doing exactly what we were doing before, just a bit more explicitly. Creating this catch session object, applying the command line, capturing the return code, and then running everything. There's a few different places you can hook into this. It's all covered quite well in the docs. So depending on what you want to do, you only have to do the minimum amount of code. So I've given us some places that we can start playing around with the command line here. So I consult my notes. Right, let's assume that we've got a couple of variables that we want to initialize from the command line. So the first thing we do, bring in the Clara namespace. Okay. And whoops. And here's how we grab the existing command line parser. And then we can do something to it, and then we can pass back a modified version. So that's still not going to do anything new. But now what we can do, let's put this on an extra line. In fact, okay. So we're going to create a new option for our height variable. Give it a hint, and these are the command line names. Sometimes I have to fight C-line a bit with my formatting. Okay. So you can see it's a little bit of a DSL to do this the command line specification, but that should now parse height for us. Let's just write it out down here so we can see what it's doing.
You intend to do dash G.
Sorry?
You're sure it's dash G for height. Does that make sense? Is that intentional?
Line 16.
Line 16. Oh, G. I originally did H, for I remember that's already the option for help. In fact, you can override them, and I'll show you that in a second as well. Let's finish this. That should. I didn't make any more mistakes. That should be it. Okay. So if I fact, if I do H, whoops, that also shows us help. So you can see the new option at the bottom. It's there, it's all nicely formatted, didn't have to do any extra work for that. That's the hint that we put on the first line there. It's still type safe, by the way, you'll be pleased to know. And if we use that option, so -G 42 of course, there we are. See, it's got the height for us. So Catch doesn't know anything about this, but it's actually done the job of passing it off to the command line parser for us. So I mentioned we can also override things as well. If we put something before the existing parser, so -N and --name. If you look in the help, you can see that's already defined for suite name. I need to talk to them about that. Okay. Right. And we'll write that out as well. So we have to put it first so that it gets processed before Catch's own one. There it is. But it's not quite perfect yet, because if I now show you the help again, you'll see our new -N, hijacked names at the top, as we expect, but so is Catch's one there as well. So do need to do a little bit more work there to remove those, but I think overriding existing options is less useful. So I've put this in now so that people can actually start adding their own command line parsers quite easily. It's just a few lines of code. Not in the documentation yet, that will go in soon. So that was the new Clara I wanted to show you. And if I switch to the Catch self-test project, I'm not going to do a lot with this, I just want to show you an existing test case for benchmarks. So here's one of these special tags, !benchmark. That's the only thing about this test case that suggests that it's anything special. As before, we've got place for common setup code, and then we use this new macro benchmark. Looks like a section. Give it a name, like a section. Block of code. The difference is these aren't run in isolation. Actually, each benchmark section will be just run in a loop until it sort of hits a timing resolution threshold. But then it will carry on, so we'll run multiple benchmarks in one go here. We can put those in sections, and then they will be run in isolation, so you've still got that choice. If you've ever done any micro benchmarking before, you'll know it's important to actually do something with whatever the benchmark was working on, otherwise it just gets optimized out when you do a release build. That's what those sort of things are. This is just a test case where I'm loading up vectors and maps to try and get some relative timings, and we can run that, do the release build, and if I expand that, you'll see here's the output. So at the moment it's just a table, shows each benchmark name, number of iterations it ran to give sufficient timing, the actual elapsed time in nanoseconds, and then the average, which is just literally dividing by the number of iterations. So it's very simple at the moment. What I'm going to be doing more of is running multiple samples of these, so it can then do statistical analysis on the differences. Because if I run this again, you'll see, particularly that last one, the numbers can fluctuate quite a bit. The longer running ones are slightly more stable. So if we run multiple samples, then it can say, well, they fluctuate this much, but it's got a standard deviation and so on. That's what most benchmarking frameworks will do. So there's something to build on. And then also, this is going through the console reporter, which is the only reporter that supports them at the moment. But we'll be adding more reporters that will be able to do like HTML graphs and things like that, potentially. The other thing it can do, if I show the help, I've got this command line option I've added, benchmark resolution multiple. Bit of a stopgap, but at the moment it's running, initially does some little timings of the system clock to see what the minimum resolution is. And then it'll run for a multiple of that amount of time, which at the moment is defaults to about 10. That's probably a bit too low, so just to experiment, you can specify a different number here. For example, do 100. There you can see it's run a few more iterations. 1,000 in the case of the last one. You can really notch them up a bit. So much so the formatting gets screwed up. So, yeah, if you do want to try this out and you're finding that the numbers aren't reliable enough, you can run a few more iterations that way. So that's just the beginning. So, that's what I wanted to show you. Just the last couple of slides, I promise. Now we're going into the future. So in fact, previous versions of this talk, or talks on Catch, I've had this slide at the end, talking about what's coming up in the future. So I just wanted to see, first of all, how we're faring on that. So we talked about matches already. They're now in. We could do with a few more, but I'm happy to tick that one off. So we've got that. The bottom one, a new name. What this was about was people started complaining that the name Catch was not very Googleable. Not only is it a C++ keyword, but it also comes up quite often in the context of unit testing. So trying to get all those few things together, for some people wasn't yielding good results. Other people said they had no problem.
You'll have to change the photo on
Sorry?
You'll have to change the photo on the title slide.
Well, bear with me. Because I didn't take it seriously for a while, and then I thought, yeah, let's do something with this. But either we go with a completely different name, in which case you lose a lot of momentum. I didn't really want to do that. Or you go with some sort of derivative name that still includes the word catch in it. And the problem with that is that people will then just still carry on calling it Catch. So I've taken the easier way out and gone with the second option. And in fact, the new name for Catch is Catch2.
What are you going to do when you get to version 21?
A big part of calling it Catch2 is because, well, it's C++ 11. It's the second major version. Multiply those things together, you can't really get away from it. So yeah, I did think about it. But yeah, it's not the ideal solution, but it's slightly better than where we were before. And I can make it slightly better again by just branding, really. Like doing talks, for example. I've got Catch t-shirts. Very limited run at the moment, so I'm going to have to make Catch2 t-shirts done. Catch mugs as well. So it's going to try pushing that name, and hopefully it will carry through enough that maybe some people will find it easier to search for. Because I think it is just too much of a risk to completely change the name at this point. So that's the third option. The first one, by the way, generators, that's not done yet. In fact, I did do a proof of concept about a year or so ago. That worked quite nicely. There were some problems early on, but the code was getting very noisy because it was still in the C++ 03 context. So I deferred it to Catch2. So now we're there. I'm going to pick that up again. And this is really just a way of doing data parameterized tests. It's also the basis for a different type of testing called property-based testing, which I also want to build in. In fact, my proof of concept did include a minimal property-based testing framework as well. And that also suffered a bit from the performance issues we talked about. So all these things are connected. So that's still ongoing, but we're getting closer. So what does the future look like now? So I mentioned generators already in property-based testing. The other thing I've been holding off for C++11, for perhaps obvious reasons, is threading support. That's really tricky to do before C++11 without any external dependencies. Should be fairly trivial now. And by that I mean not running multiple test cases concurrently. I think that's best done at the process level if you're going to do that. But more, if you have a test case that spawns off a load of threads and those threads do some work, you should be able to do assertions within those threads and it will still work. You can't currently do that reliably. And then a couple more things. Out of proc, or sometimes called def tests, been a big request for years. It's just a big chunk of work, again, with no external dependencies. Even C++11 doesn't really help you. But it is important, do want to do it. So this is where Catch itself will spawn another process to run some test or some group of tests. And it can do things then like check that a test actually, or some code, causes the program to terminate, which obviously you can't do in process. But it's also useful for running individual tests in full isolation. That can be important sometimes as well. So definitely important. And then type parameterized tests. So like the data parameterized tests, but if you've got, say, a template and you want to check that for multiple instantiations with different types, a set of properties always holds. It's actually fairly easy to do it manually, which is why this has been a relatively low priority. But it does keep coming up, so I will get to this one at some point as well. There's always other things on the backlog, but these are the main ones that I get asked about. So that's pretty much the end for now. That's the set of references that I talked about. So my website, which is levelofindiraction.com. If you can't remember that, I've also got extra levelofindiraction.com. That redirects there.
Not level of indirection 2.
That's cunning. /storage and then /catchrefs.html. I'll leave that slide up for a minute if anyone wants to take any notes. Or you can hit me up on Twitter. I'm Phil Nash. And this has been Modern C++ Testing with Catch2. Thank you. Do we have any more questions? Yeah.
So how do your micro benchmarking, how does it compare with Google's benchmark library?
I haven't tried Google's benchmark library. The one I have tried recently is called Nonius, which itself uses Catch to test the framework. So a lot of my ideas of how it should work are based on that. They all seem quite reasonable though. I did look at the Google one, but again, like Google Test, I just found it that I was getting put off by how much work went into just getting it set up. Which is one of the reasons I want to put it in Catch. So if you've got Catch there, you don't have to do any work to get it set up. It's just automatic. Yeah.
So one of your first slides, you said in order to get people to test, you have to make things simple. How do you go from moving from a test framework that is not so simple but widely used in your team to something that is easier but not used yet? And is it not making it more complicated?
So if I got you right, I think there's a couple of parts to that. So you're saying you've got a team that's already on some more complicated test framework. Could be anything, Google Test. How do you get them to start using Catch, and doesn't that make it more complicated? Depends on your definition of complicated, and I've done a whole talk on this. But in terms of introducing more things into the mix, yes. But in terms of the code that's using Catch should be simpler. There's going to be less complex code, at least on your side, hopefully. But there's more things to learn, so back to more complexity again. I think really it depends on what the team feels. You can't force them to take on extra work, but if they're all for it, then I think it will be easier. From time to time I get asked, is there a like a translation layer, so you can take your, say, Google tests or Boost tests and just run them with Catch. And I haven't done anything like that. I know a couple of people have done something, at least for their own code base. I imagine it will be much easier to do something for your code base than a more general one. So that's a possible option. But I think running them in parallel and just increasing the Catch tests and decreasing the Google tests or whatever it is over time is probably the best option for most people. Does that answer?
So 2 questions actually. So you're only using Mac OS, but I suppose it works on Linux and Windows.
Oh yes, yeah. So in fact, when I was first developing Catch, I was doing it on the train on my MacBook Pro, but I was using it primarily in my current day job at the time, which was Windows at a bank, Visual Studio, 2010 originally. So that was always a high priority.
And the other question is, at work we are using Google Test, of course. And I actually, out of curiosity, I was using CLI, and I noticed that it integrates with CLI. So CLI parses the results and gives you the kind of a tree with the tests and results. Does it Catch integrate with any?
It does, and I should really have shown that.
Yeah.
I'm so used to the console reporter, I actually still prefer that.
Yeah.
But yes,
It's no big deal.
It does work. I even, as I mentioned, with now the ability to run individual sections.
Yeah.
The C-line integration works with that, so you can get it to run just an individual
Because
section.
I believe Google Test there's an extension to integrate it with Visual Studio, I think.
Right. In Visual Studio, you can do it with C# or C++. That has its own test runner. But I think the recent versions of Visual Studio, at least 2017, and I can't remember if 2015 is true, they've reworked their test runner so that it's easier for third-party integrations as well. So it's something on my list to look at that as well. Yes, to the back.
So philosophy of testing, you went to talk about that at the beginning. Why do people not like writing tests?
Oh yeah.
So test-driven development basically works like this. First, you tell the computer how your program is supposed to work, and then you tell your program the computer how your program is supposed to work. Essentially, you write the program twice. Is perhaps the need for testing due to the fact that some of the programming languages we use can't really express what you want to do clearly enough?
It's a very good point, and it's a very open-ended one as well. But I do have an opinion. And this plays into the whole debate about static versus dynamic languages, which we can probably thrash out more at the pub. But for me, one of the strengths of statically typed languages, particularly those with a good type system, is that you can encode more of your constraints and requirements in the type system. So you don't have to write so many tests. And there are other things as well that can reduce the amount of testing you need to do. Obviously, fear improvers and those sort of things are one end of the spectrum, but they're not quite ready for the mainstream yet. But in the middle, you've got things like languages with, say, a REPL. You can do a lot of the TDD cycle within the REPL without actually having to drop down to tests. And then when you've got things into a decent form, you can translate that into what's left into test without doing the volatile bit in final code, if that makes sense. Yeah, I do a better job of explaining that in the context of Swift, where I do a talk on using Swift Playground, which is like a REPL to do TDD. But yeah, you could do more of that cycle without the formality of the test framework, should we say? Yeah.
Does Catch2 allow you to test to see if an exception has been thrown?
Does it test with an exception?
Take back the .app, for example. It throws an exception if you pass in -1.
Yeah.
Would Catch be able to detect an exception is thrown? I don't know what the exception is. I just want to make sure that an exception is thrown.
Yeah, so Catch wouldn't be a very good name if that wasn't the case. So it's actually got very good support for checking that exceptions are or are not thrown, and if they are thrown, what the type is, what the message is, and that sort of thing. in fact, one of the things I did more recently, on sort of layering on top of the matcher support, you can check that if an exception is thrown, regardless of what the type is, it will hand off wherever it needs to something that will translate the message into a string and then pass it to a string matcher. So you can say whether the exception message contains these things or starts with an end. Because the trouble with exception messages, because they're usually or often intended for end users or at least developers, the strings might change. So you only really want to verify that they contain certain things rather than matching an exact string. So it's got support for that sort of thing as well. But yes, in terms of unexpected exceptions, if an exception is thrown and you haven't said you're expecting an exception or expecting it not to be an exception here, it will still catch it outside and do its best at reporting roughly where it was as well, based on the last line number that it knew about. So, yes.
Can you assert on the benchmarking? So that it reaches a certain performance.
Yes, good question. In fact, the code I showed, there were some assertions in there, but I was very careful to keep them outside of the benchmark. Now, you can put them in there, and I'm probably going to put some checks in to prevent you from doing that, at least at runtime.
Assert on the actual performance itself.
Because, so on the performance itself.
So
right.
this run should run within 10 milliseconds,
Right.
does it?
No, not currently. And I have toyed with that idea. In fact, I've done something very similar in-house on a previous project. And of course, the big problem is it's not reliable.
Suppose that would help with, I suppose that would help with regression for performance.
That's what I was thinking.
Yeah.
Say have a minimum requirement,
Yeah.
it must match, must be within 10 milliseconds.
So the trouble with doing that automatically is that it will often fail intermittently.
Yeah.
And if you're happy to live with that, then yeah, but I'd like to keep that out of the framework and maybe the upper level. But it's certainly something you want the reporter to output the results in such a way that something outside of that could then do that sort of checking, I think.
I have another question.
Yeah.
It seems like you're really into this kind of stuff and you're testing. Do you ever come across the problem that it's something that you normally find that you test easy for like self-contained code, like vector, string, whatever. But then when you come across this kind of thing that, for example, games development, that's why I'm asking. You have the renderer, which gives you an image, right? Do you ever come across this problem that you don't really know to test this kind of stuff?
Yes. From my understanding,
You're talking about the games, so the game's supposed to generate a frame, and you want the frame to be that thing, but you can't really figure out.
There's a few parts to this.
Yeah.
The easy answer is to say, well, that's not a unit test, that's an integration test. Which you can also do in Catch, but that's a bit of a cop-out. The way to really solve that is twofold. One is by making your code as sort of loosely coupled as possible, you minimise the times that that's an issue, which of course is really, really hard if you've got an existing code base. In fact, almost impossible. It's hard even if you're starting fresh, particularly in a domain like games, where, or any domain where you've got some really tight constraints and certain design principles go out the window. The other side to it is mocking frameworks can often help here. So you can create a flake object that will play the role of a collaborator, and then you can test your thing in relative isolation. Catch doesn't have mocking built in, which is another thing I'm frequently asked. But it does play well with two mocking frameworks I recommend in particular. HippoMox and fairly new one called Trompe-l'oeil, which is French for trick of the light, not trick of the light, something like an optical illusion anyway. If you're interested, I can give you a link or something. They're both slightly different in that Trompe-l'oeil aims to be implemented entirely within the realms of defined behaviour in C++, which is really tricky for that sort of problem. It does mean that it's a little bit more verbose to use. Whereas HippoMox is quite happy with undefined behaviour, as long as it just works. And as a result, it's actually a lot simpler. In fact, I was thinking of HippoMox during your talk, because the tricks that he uses to implement interfaces at runtime I could see perhaps simplifying some of your RPC stuff. So yeah, you should check out Hippomox. The guy did a talk at CPP, C++ now this year.
Thank you.
Yeah, so they're the two sides to that question. Yeah.
The section thing is quite interesting because at work I've been pushing for the arrange actor set pattern that have been really helping making cleaner tests that are not doing a bunch of stuff. How do you basically fight complexity with the sections? Do you find that do you have to use tricks to keep things simple, or to organize them differently?
There's not a simple answer to that. I find it's just a case of I'll be writing something using sections, seems like a natural fit, and at some point I think this is getting quite complex, and at that point you just start splitting it out. Just like writing any code, really. You split things out as they become easier to work with that way. So you treat the test code as you would production code, with the same eye for design principles. Another cop-out answer, but that's what I've got.
So
Yeah. Oh, sorry. Do you have a follow-on?
Any kind of big companies, big open source projects using Catch? Any big users of Catch, like any big open source projects, companies?
Yes, very good question. In the docs, there's 2 pages: open source users and commercial users. Open source users, there's quite a lot on there now. Being open source, it's quite easy to find those. Most of them are volunteers themselves.
Kind of related to the other question that how easy it would be to convince the company to adopt it. If it's not used anywhere, then it gets harder.
There's plenty there. I'm trying to think of some off the top of my head. I did mention one earlier. But in terms of commercial users, there's a very short list at the moment, because people are not comfortable saying, well, we internally use this thing. But the list itself is quite good, so I'm quite pleased about that. We've got NASA, Bloomberg, and there's another one as well, I forget now. They just recently went on there. But so even just those 2.
Keeping the rockets, keep the rockets going.
Yeah, exactly.
So I think one person had one more question, but
Okay.
so.
Yeah.
How do you usually test your unit test framework?
How do you test the unit test framework? Very good question. So I actually showed you the self-test project, which sort of has 2 parts to it. One is just loads of tests which just exercise all the different parts of the framework. They're not specifically testing it, they're just using it to make sure that all the different types of conditions and things work. And then the other part is sort of it will introspectively test parts of itself by calling internal functions. So it wasn't quite the case to begin with, but since the last few years, all of Catch itself has been written in a pure TDD style. That itself is not quite enough. So I also have a set of Python scripts that will invoke the Catch test executable with different command line options and different reporters, capture all the output, and then compare it against the previous baseline. So we'll do regression testing on the output as well. And that also checks all the reporter outputs and so on. Obviously that means if I add new features or change things, then I get loads of regression failures there. I just have to go in and approve the diffs. In fact, we call them approval tests when you do it that way. So they're currently the 3 levels of testing that's done. Could always do with more though.
Okay.
So thank you.
Thanks.
Thanks very much.